Good morning, everyone. It's 10:30. We have a jam-packed program for today. So I'm going to get going because roughly halfway through, I'm going to hand it over to Peter, and he's going to roughly try to finish it up, and we'll try to speak twice our normal pace so we can get through all this stuff. So today, my first part of today's lecture will be on using AI to generate images. Now, I know you've done this before. You've done it for assignment 2, haven't you? We're going to do it again in class, and we'll talk about some of the details of why. But first, I want to talk about AI news you can use. You might remember Tuesday we had Steve and Michelle talk to us about the Center of Robotics work that they're doing. So I thought we would look at some recent robot news. This one struck my eye because in Japan there is convenience stores. And as you know, the problem in Japan is they've got this huge age demographic problem, and they can't find enough young people to work in the convenience stores. So, being Japanese, they built a bunch of robots. And as Michelle said, the dexterity manipulators for robots are not so great. And so, what you've got is, oh, I thought I had another picture, I guess not. When a can falls into one of the in the convenience store, they send a robot. But the deep, dark secret is the robots are teleoperated by people in the Philippines. So it looks like there's robots, right? The other thing to know, just on background, on deep background, is you might remember the party that was the first demo for the Optimus robot by Tesla, right? They were walking around handing out drinks and doing all this stuff. And the deep dark secret there was they were not autonomous. They were all run by people in the back. They were also teleoperated the same way. So we still need more work in this area. You might have also read this, that Amazon wants to use robots to avoid adding 500,000 new jobs. That's a lot of jobs. They're not taking 500,000 jobs away as far as we know, but they're not hiring humans. But what's interesting is most of the jobs are in warehouses moving heavy lots of junk around. And so I've got a little video here. I'll show you a little piece of it. This is another one. These are all the robots in the warehouse. Giant industrial robots, just like the first one we saw. Special effectors on the end. Giant pallet moving thing. These are not robots. They do not require much dexterity. Let's just okay. I'm going to say about robots. Lots of great work going on. Talk to Steve and Michelle if you're interested in following up. I do want to talk about creating images with AI. And so we're thinking about this as sort of augmenting intelligence, because you can draw, you can paint, you can do all that stuff. But I'm going to give you an AI tool to help you do that better. That's the way I like to think about this. So in times past, like 6 months ago, when I do this lecture, about 5 to 10 minutes about the basics of stable diffusion, the algorithm, how they generate. I'm not going to do that because it's a little bit like telling somebody how carburation works when you're trying to teach them how to drive. It's irrelevant to the input control mechanism. So if you want to find out about this, I recommend watching these 2 videos. They're quite good. If you're really interested in getting into the algorithmic details, go for it. It might help you a little bit to understand what the parameters are that you can change, but that's kind of it. Okay. I do want to talk about, however, Deep Dream. How many people know about Deep Dream? You know, anybody? Okay, this is a few years ago, like 5 years ago, which means it's an internet millennium ago. And it was basically a face recognition identification program done all with convolutional neural nets. And people noticed that it was making images like that. What? What is going on? What kind of drugs am I on that this is happening? And it turns out that this is a standard convolutional network architecture. So you've studied these before, you know how they work. And the goal of this network was to be able to identify, to find faces in images or whatever you tuned it for. In this case, it was searching for dog faces. Some clever person said, oh, what happens if I look at the 3rd layer back and take the image representation from layer 3? And that's when they discovered that you got these wild psychedelic images like that. what's going on is revealing to you that what it's doing is trying to aggregate little pieces together into coherent wholes. In this case, really weird dog faces. So that's why you get dog faces on the edges of spires and in the sky and all that sort of stuff. Well, another thing that came out of this work was the realization that you could capture a style. Pause. Today's talk is going to be a lot of different UX image generation idioms. This is idiom 1, style. So people realize that what you could do with these systems is to take an image and say, hey, I want to identify this as a style. You train it on a bunch of, say, Van Goghs, and we'll call that the Van Gogh style image. And then you can say, redraw this content image in terms of this style, right? And what you get is something like that. You could do the same thing with Marilyn Monroe's. You get Marilyn Monroe's in the sky, you get cypresses, et cetera, et cetera. So there's a reference for you if you want to find out more about that. The important idea for us today is that this notion of style will reoccur multiple times in different domains. We're looking at it here in terms of image content. It happens in terms of audio content, video content, et cetera, et cetera, et cetera. Okay? So here's an example where an image generation system was trained on this particular artist's work. This is all original work. Trained it up and said, this is this artist's style. Now I can re-represent, and now I can generate new imagery within that style. So it's just like if you went in the 18th century to a Rembrandt studio, it became a studio. You learn Rembrandt style, and now you can generate arbitrary numbers of these things. So this is an important idea. The second thing, yes, ma'am.
Right now, the sentiment is that doing that kind of style copying is copyright infringement, but like this model has a history. You go to a master studio, you learn their style, and then you go.
Yep.
It's like, I guess, the issue that like we don't. It's violating the copyright law.
Yep.
What is the?
That is an excellent question. I recommend you ask Pamela Samuelson that question on Tuesday, because she's actually the current expert on this. So that's a plug for the next week's talk, which is great. Second thing, we actually will come back to that topic at the very end. So we'll come back to it. So, but it's a really good point, because what happens if you create the style guideline for a currently existing artist? Hard problem. So the next thing you can do once you get this sort of style thing is you can start to think about multiple image merge. And you can do this with 2, you can do it with 10, whatever. You say, these are the source images. Here's the master. So the source was the woman. The background style reference is the dreamy landscape, and you can merge those in that way. Now, as you probably have noticed, there's been this huge explosion in image generation systems. And there are endless guides to how to make prompts for your cool image style. And you can go read them like that. A lot of them include really helpful things like use these emojis. And it's unclear to me that they actually do anything. I mean, maybe one bomb explosion emoji works, but why does 5 do better? Answer, no. So there's a lot of weird advice out there, but there's a whole bunch of skill in making these text prompts to generate the images you want. Big point to make. This stuff is changing very, very rapidly. So here is the evolution of one image. That's the prompt, cherry blossom near lake, snowing. You can see how much it changed over the course of a year and a half. Or eerie forest, black and white. This is an important thing. This is not going to stop this year. It will continue to improve in interesting ways going forward. Style incorporates many different kinds of aspects, not just color choices and brush strokes, but also sort of how to integrate the idea, in this case, jellyfish. So here, using the Google style tool, we were able to take an image of a statue and re-render it with jellyfish. So there's really new, interesting, expressive possibilities here. So one of the debates that comes up all the time is, isn't this destroying the value of artistic interpretation? And it reminds me a lot of the debate about before I was born, but I've read these books. At the time when photography was introduced, people widely thought, this is the death of art. It is the death of painters. And that's not what happened. We have a new art style, photography, and there are just as many painters now as there were back in 1926. So this kind of thing is just redefining the edges of what art is. And it's also changing our perception of what style is, because this is Midjourney 6. And if you remember pictures from back then, they had a kind of AI look to them. And things have gotten better. And so Midjourney 7 now, that looks like a photograph. It's completely generated. And so they were able to tune the system. If you say hyper-realistic, it will generate something that looks hyper-realistic, like just like that, and not the AI glowing appearance. So I'm not going to read this. Read this on your own. Basically, one of the big tropes of image generation is, how do I tell it? How do I bridge the gulf between what I'm thinking I want to see and what it's going to do? So you can prompt all kinds of things, including in the style of, in this case, you can guess who that style is. And that's so far completely legitimate. We'll come back to that. Another kind of thing you can do is think about characterization in the sense of a cartoonist. So here's an image I found. I kind of like it. I'm going to tell Gemini, look, this is going to call this landscape style. So I have named the style. Okay. Now this is using Gemini's Nano Banana image tool. Now I can say, here's another image. Take that and generate, and it generated this image on the left with the Northern California coastline. That's not exactly what I wanted. I said I want a picture of Big Sur, so you can put the bridge there. It does a better job. Not bad, not bad. So this is working with pure text prompts based on the style image I gave it, right? Now, suppose I said, apply it to a photograph. This is a picture I took also in the north coast of California. And I said, render this image in this style, following the style guideline. And it kind of does a half-baked job. It only did one little hill. Like, and trust me, I tried multiple times, multiple ways. Never got it to do anything more than that. However, I used ChatGPT in this case, did the same thing, called it landscape poster, same idea. I said, render this in that poster style, and it does the whole thing. Moral of the story, different systems give you different outputs, right? Learn what the capabilities are of the space of image generation tools, Midjourney, Firefly, Gemini, and then blah, 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 right, them all. And prediction, there are going to be 20 more next year. It behooves you to spend a little bit of time to understand what these all are. So I want to spend literally 3 minutes, and I recommend people with laptops go to that URL rather than the QR code. Doing that on your phone is hard. You could use the URL, you can use QR code and then copy paste it to your laptop, right? But what I want you to do is to do kind of what we did in assignment 2, except it's going to do this in an odd way. So that's the URL, tiny URL, HCI-AI-Stanford. Use any of your favorite image gen tool, Chat, GPT, Gemini, Leonardo AI, Firefly, I don't care, use one. And what I want you to do is generate a diagram of a toaster. I'm going to give you 2 minutes to do this because you're all talented people. 2 minutes. And then what I want you to do, oh, I forgot to put that up there. My mistake. I'm going to put this up here right now. Oh, that's not the right one. Arg. Gen AI images. There we go. So here's mine. And what I will do is give you a QR code. Now let's do this. Sorry, you get to watch the sausage being made here. Stanford Image Gen. Spreadsheet. HCI AI sheet. There we go. So go to this URL to upload your image, if you would. Okay. And then what I want to do, in 1 minute, we'll go to that spreadsheet and see what you've done. Create a new tab, put your name as the name of the tab. So Peter's making a tab, and he's going to name it Peter, and then he's going to copy paste his image into that of a toaster, right? So I need you guys to start creating tabs down there. You don't think you can edit this spreadsheet? Oh, I see everybody's there. So I'm going to make you all be editors. Voila. Now you have. Yeah, you might have to reload. I don't have to reload. There we go. Thanks. And while people are uploading theirs, I want to show you mine in a little detail. That is not a resolution problem. That's because the text is not at high res. That's in this case ChatGPT failing. And there are parts in there that I don't recognize that belong to no known toaster. Okay, so page. Let's see, sheet 9. Anybody have one we can look at? Okay, who's got one that we can look at? Okay. Like this. Okay, you see the difficulty here? Thank you, that's a brilliant. Hot zappy coals. What was your prompt? Did you put your prompt in here? Yeah, great. Anybody else have one here? No toaster I know has a cancel button, but that's kind of cool. That's actually better than most. Okay, Peters has got a nichrome element, awesome. Electromagnetic latch. This is bad. Bread cage carriage. There's also a lot of electronics down there in the bottom. Jackson, where are you here? There you go. Oh yeah, the X-ray view. Yeah, very good. It actually is not bad. That's better than like the one I did. These are great. Okay, but you see the point. You thought you had with the invitation problem. Toasters are difficult. Let me show you one other just for fun. Here I asked Firefly to give me a picture of Stanford campus. That is not Stanford that I understand or recognize. Right, and it only gets worse. I asked for where's the computer science department at Stanford? Again, the deep point here is doing accurate representations of diagrams and maps and stuff. In an image generation program is not the right problem for the tool. You are not going to get high quality diagrams. So if you ask, for example, for an electronic schematic, say, give me a simple LED oscillator using a 555 chip, forget it. It's not going to happen. Right. So thank you for all that. So image synthesis right now, the major UI element for most of these is inputting. So I say, I want a cute corgi that lives in a house made of sushi. You know how to do this, right? And these images are awesome, right? They're totally great. And you can generate all kinds of things, including house plans and stuff like that. Interestingly enough, these things have gotten so much better over time, except for diagrams and maps. So you can see how much Midjourney has improved in its image generation quality over the past couple of years. And so now this is really, really good. You get the idea. Of course, you can generate people that never existed. So if you're in marketing, it's a great way to circumvent any kind of copyright issue. But there's a caution I'll give you in a second. But be very careful, because you can do deepfakes. There's the famous Pope in the Balenciaga puffy coat. This is not a real image, but you now understand deepfakes are a real issue. And we're not going to talk about nudifiers, but I found the anti-nudifier, which was really quite interesting. If you put in David, it puts boxer shorts on him. But understand, you can manipulate style to include things that you may or may not want to have. Another major UI idiom for image gen is the notion of in-painting and out-painting. Like the other idioms, like style, this has extensions into other media as well. So we can talk about in-painting and out-painting for audio. So the key notion of an in-paint or out-paint is that in-painting allows you to fill in more detail within an existing image, and out-painting hallucinates outside that image. So, for example, that's the girl with the pearl earring by Vermeer, and this is an out-painted version of what the surrounding they think it looks like. Doesn't look like any house from the 18th century Amsterdam that I know of, but whatever, right? Of course, when you do outpainting, you're asking it to hallucinate. That's exactly what you're doing. Give me some more like that, just make it up, right? And for certain kinds of things, it can do really, really well. There's a really brilliant video of outpainting while flying over a beach, and it's just getting more and more beach as it flies along. It's really quite compelling. But you have to be careful. Make sure you know what it is it's painting. A third major UX idiom for generative AI is using sketches as input devices. So a lot of generative AI is built by text prompts, but now you can increasingly use sketches. So use a sketch of a horse, and you can ask it to re-render that as a line drawing of a horse. Or you can start with a sketch, hand-drawn sketch, and have it re-rendered as a high-quality 3D portrait. Or you could do snails, and then set it. You get the idea. Sketches as an input element. There's another whole mechanism called control net, where you can actually take elements of the image and move them around, just like it has, you've got line drawing with control knots. Do that now with images in the image editing program. I'm going to skip over this one because this is that same idea. It's just a video for you to watch later. Okay, so copyright, right? So there's a lot of examples of artists being really infringed upon and then filing suit and so on. And this is a nice example where a bunch of Holly Mingert's illustrations were used to generate a style guideline. And of course, the mouse is infamous for pursuing copyright. And one of the things to recognize is that Mickey Mouse in black and white is out of copyright. You can use Steamboat Willie and Mickey Mouse freely. That's out of copyright. But using versions like this is questionable, okay? So what should you be doing? Here's what you should be doing, you as a consumer, as a student using these kinds of things. Take your test sample that was generated and then do an image search to see where possible infringements would be. This is what Google image search is really, really good at, finding close, similar matches. So you can actually do that and say, oh yeah, there it is, it's on the Disney website. Maybe I should avoid that. And I'm getting away with this because this is fair use under education clause in copyright. Of course, we can do style guidelines for classical artists as well. That avoids the copyright problem. Botticelli is not going to sue you for rendering Keira Knightley. Of course, Keira Knightley might be annoyed, but the artist's legacy is not going to come back and try to get you. And then you get into the more difficult cases like Andrew Wyeth. So here's an actual Andrew Wyeth on the right-hand side. And as of 2 years ago, a year ago, you couldn't do a very good emulation of that. But now it's getting better. This is a year later. And then this was from last week. So these are getting, the style renderings, the style interpretations are getting very, very good. Here's the fifth idiom, whatever we're on. We can now start to think about making 3D models from images. And there's a whole pile of work. This is a really nice paper I recommend to you. Basically taking a whole bunch of images, drop in a new image, and then say, give me a 3D model of that thing. So, for example, here's a bunch of pictures of a dog. Now put the dog into the Parthenon, or turn it around backwards, or whatever you want to do. The idea is once you have a 3D model, you know what the back of it looks like. How does it know what the back of that dog looks like? Because it's seen other pictures of other dogs and the backs of those dogs. And therefore, it's doing a hallucination of it because it doesn't really know. But this is really, again, this is another one I'll let you watch in your own time. But this is actually a really lovely, a guy who's a real full-time artist using AI, and how he walks out and uses AI to support his professional illustration practice. Now we've got the ability to take multiple images and combine them and start to put them in video space. I made a little video here using a system called HeyGen, which took me speaking and me teaching a class, translated my English into Spanish, did the voice production of my Spanish language voice, and then synchronized my mouth movements. So I'll show you a little bit of this. And I speak Spanish, but not this well. You get the point. You know, it's pretty good. So there are entire companies, and this is what they do. They have avatars that can now do a better job than I can of presenting my own material. We should get avatars to do a lecture, Peter. Just think. So Synesthesia is a company that does this. You choose the avatar, you give it the voice, you choose the text, and it'll produce, I'm not going to show this either, we'll just skip through it. It shows you how to edit your way towards fully realized live video or synthetic live video. There are people doing immense amounts of work on synthetic video. So there's competitions for these things. This is sort of fun. I recommend it to you. I know, like I said, I'm giving you an entire talk in half the time. But I do want to point out two more things before I hand it over to Peter. There are new idioms being developed for video as well. So we have the notion, for example, of brushes. If you've used Illustrator or any paint program, you get a brush, load it up with a color or a texture, etc., size, and so on. Same thing can be done with brushes for motion in video. So I'll run a little bit of this clip to give you the idea. Here, selecting portions of the image and then saying, animate that. So that's the indicator. And then in the background, you get a text prompt for how you want that background to be animated. You get the idea, right? So, well, isn't that interesting? That's my video. You've all seen this before. Basically, you can an image on your phone, select a person, item, a background, or something, and erase them, and it will then in-paint the missing text. This used to be done in Soviet Russia to make generals go away. And we talked about earlier about making people go away in images that you have and that affecting your memory. I'll let this one because this is the same idea applied to audio. You hear the wind? It analyzes it and it takes out the wind channel. The wind. This is the same idea. We talked about this in the context of music, where you're looking for stem analysis. And now we can do similar tricks for other visual properties. So here's a video fiddling around with the focus. So the original image is on the left. the synthetic images on the, how did they get the focus image? They're hallucinating the higher resolution. So it's the same idea as the in-painting stuff we've seen before. So I want to, this is the last video I'll show, then I'll hand it over to Peter. There's another interesting idiom in both visual static imagery for image generation and for video generation, which is the notion of having a character. In this case, a semantically meaningful object. In this case, this wacky toy that this guy has. I'll let this run for a little bit. He takes a picture of it, creates a character. He then goes on and does that for video. And that's basically one of the things that Runway is really good at. Runway is here now. It's currently top of the pack. It will maybe go away next year. There will be something else. But be aware that the underlying concept in scenes with motion that's identified by paths, manipulated by parameters, is a concept that will be around for a long time. Yeah. So what, from our perspective, we've got all these things, these key ideas. And I want to show you this last video because this is not real. This is a synthetic video to demonstrate a new UI technique, which I think is rather clever. It's actually 3D physics modeling of objects in the world and manipulating them as though they were items in your painting. So here, that's all sim snow. You can see how this would work. Imagine a text prompt that says, remove water, and then you use your mouse to brush away the water. Or grab a corner of the sheet and wiggle it. Or again, that's not there yet, but it brings up this really interesting ethical dilemma. Suppose we can simulate any artist, any video, any animation. What do we do about it? Bring up this is my last slide, and I bring it up because in 1982, National Geographic got caught out. This is pre-Gen AI, right? They got caught out photo editing the pyramids. A lot where the pyramids are. Turns out they moved a couple of pyramids around, and they put that on the cover, and they had to backtrack big time. So they got a lot. This is not a copyright issue. This is a representation of reality as truth issue. National Geographic has a reputation to protect of giving you beautiful images of real things. And yet they had the motivation to move stuff around in Egypt. So we've talked about all these idioms. I think I'm going to stop that because you got the idea. Okay. Let me turn it over to Peter and set him up to go. It's all yours.
Good. So these are the two biggest applications we have are for generating images and language. So let's cover the language now, and you're all familiar with this. And you know, it used to be we used language to solve sort of specific problems, but now we can do anything, right? So we can say, I want to decorate my bow window, or I want some recipes, and I want to find another recipe that goes with it. We're just broadening the range of things we can talk about. So how do we get there? Here's some examples of winning competitions lately. So these language models are competing at the top level of mathematics and programming competitions, but they also make lots of mistakes. And this is old, but every day we're making mistakes. These models are doing amazing things where they're competing at the level of the highest mathematicians and the best programmers, but they're also making mistakes that a fifth grader would know immediately are wrong. So they have this kind of jagged performance where they're really good at some things and not so good at others. And the question for us is, how do you use that without falling into those pitfalls? Okay, so let's take a couple minutes and just discuss with your neighbors, what are the things you're worried about? What do you think can go wrong with using these language models? Possible pitfalls is the worst for you? And are those types of problems different with large language models than they are with previous technologies that have pitfalls? So take a couple minutes and discuss that.
Biggest problem.
All right, let's bring it back together. What'd you guys come up with? What problems are you worried about? Who wants to volunteer a problem to discuss? Anyone? What'd you talk about? What'd you guys say?
We talked about our top three were hallucinations, bias, and privacy. I think we said that the hallucination is definitely different than past tech, but we were talking about how like the belief in how like kind of taking it as a dogma is what makes it different than past tech.
Yeah, so I guess there's something about it just kind of being in black and white in that way. It is more convincing, right? If you can make a coherent argument, it just seems more real. Anybody else? What else do you talk about? So those are three good ones. Any other ones, or anybody want to second that those were important for them? Yeah.
Talk about like confirmation bias and like if you over it. A lot of times like they want to validate or like you're saying, especially if you treat it like the first time you have like two models in which you can interact with like natural viewers or how you and then that establishes a lot of trust, but it is still a model of actual reasoning to ethical thinking.
Yeah. Yeah, so I think that makes sense. You know, I'm seeing all these examples of confirmation bias, so it must be true. And I guess that's, you sort of go down the rabbit hole more if you're having an interaction and getting a response. And I think part of that is actually the way these models are tuned to apologize and agree, right? So if you say, no, that's wrong, they'll always say, oh, I'm so sorry, and then come back and agree with you rather than pushing back and saying, no, you got it wrong. Anybody else? Okay, so I'll go over the list. And there are a lot of the stuff that you already mentioned, hallucination, human gullibility, I think that's what you were getting at. Misinformation of just there was something wrong that it repeats, disinformation of actively trying to say something wrong, bias you mentioned, copyright, Dan mentioned that earlier, that's still a big issue, and privacy. And then it's just that these are powerful tools that used to do bad things. And I guess there's a question there, is that really fundamentally different than things we could do in the past, right? So lots of technologies are dual use. You can use them for good and you can use them for bad. We're seeing the same thing here. One of the big questions, and a year or two ago, there was this debate, should we even allow open source models of this kind? Because have them running on a server or behind an API, then every interaction is logged. And if there's some bad guy trying to do something bad, you can catch them and see that they're doing it. But if you have an open source model, they run it on their own machine, you have no controls over that. And a couple of years ago, people were saying, well, because of that, maybe we shouldn't have these open source models. Now the cat's out of the bag and everyone's saying, well, there's nothing we can do to limit them. You can run them on a smaller machine. They're almost as good as ones. There's no way to get back from that. Some talk about the cost and the carbon footprint to create these big data centers. I think that's going to be overall a net positive. And then this idea of job and task disruption. And here you see a strike of the Writers Guild saying AI is taking over our jobs. We want to come to some conclusion over that.
It's kind of funny that the AI stuff started with Elon just saying everyone that AI is going to kill us all. If it's in the hands of a person.
Yeah. So I guess that was, there was a lot of talk of that, again, seems to back off now, of saying, people talked about a hard takeoff versus a soft takeoff, right? So if the technology just sort of advances and everybody's doing about the same thing, then it's powerful, but there are checks and balances. And what a lot of futurists were saying, well, what if one company creates super intelligence first and they're the only one that has it? Then they could impose their will on everybody else. I guess there's less worry about that now. First of all, because we've seen all the mistakes things make. So this idea that they're close to super intelligence seems to back away from that. And also, it's easy to reproduce what other leaders are doing. So the idea that one company or country is going to be so far ahead of the others, that seems less probable. But sort of the point here is that going back into the 19th century, we had these same kind of riots. So these riots came from the introduction of the Jacquard loom, which has these basically punch cards here. So that it can automatically weave a pattern and then reproduce it flawlessly time after time, putting a lot of people out of work. They were annoyed at that. Mostly they were annoyed that they weren't being paid properly, right? So like a lot of these labor-saving devices, the worker says, that's fine if it makes my job easier, but it's not fine if you discard me and push me out. So that happened. I was just reading that John von Neumann, who introduced the idea of the stored program computer, he actually got to play with one of these Jacquard looms when he was 8 years old. And his brother said that that's what inspired him to invent the computer. Okay, so I want to distinguish between natural language and formal language. So in formal language, like a language or a language of mathematics, symbols have explicit definitions. In natural language, it's just kind of, we know what you mean. And the grammar is inexact. The semantics depend on the context. Things are ambiguous. Language evolves over time. And none of those things are true for the formal languages. They're all precisely specified. So they're quite different. And yet, we have Andrej Karpathy saying a couple of years ago, the hottest new programming language is English. So he wants to take this natural language and say, maybe it's formal enough. Maybe these tools can allow us to use this. Interestingly, they're also kind of semi-formal languages. So Wolfram has this formal programming language called Mathematica, but they also introduced this Wolfram Alpha, which is a semi-formal language. It's kind of halfway in between a search box and a programming language. What do I mean by that? So you type in something and it interprets it. Type x up arrow 2/2, and it says that's x squared over 2. But if you type x arrow 1/2, it says that's the square root of x. So what's the operator precedence here? Well, there isn't any. The operator precedence is I'll do what I think you meant. And that can be really useful if you're typing these types of things in. If you're operating it remotely through an API, it's probably going to do the wrong thing part of the time. Here's other examples. So there's lots of ways in which you can say integrate. You don't have to know the exact syntax. But notice that it says, if you don't tell me what I'm integrating with respect to, then I'm going to treat x as a variable and c as a constant. So in a formal programming language, there's no difference between just variables, and you can use them in any way. Here it says c has a context-dependent meaning. So that's the tricky thing about symbols. So some symbols can be defined formally. In mathematics, we can define what a triangle is. But most other words we use can't be defined. I can't define justice precisely. I can't even define a chair precisely. Does a chair have to have 4 legs? Does it have to have a back? There's just this kind of fuzzy boundaries around them. So should we, when we're doing these language processing, should we pretend that we can do that? Or should we give up on symbols? And we come to this idea that, well, we could embed these symbols in a multi-dimensional space so that instead of just saying the only thing we know about symbols is identity, symbols are equal or they're not, we can say they're close to each other. They have some similarity. And here we project them onto a 2-dimensional space, but normally we do that in hundreds of dimensions. So we have these things called word vectors. So a word is a point in this multi-dimensional space that gives us better generalization than just having atomic words that are either the same or different. We have this notion of the transformer model, which is the current model we use. There may be a different one coming in different years, but this one's lasted for several years. It stems from this paper in 2017 called Attention is All You Need. And the idea is we want to be able to look into the past, figure out which words were important and keep track of those, but not have to keep track of all of them. And then we have this idea of adaptation, of prompting and fine-tuning and reinforcement learning. Okay, so John Firth, this linguist, said in 1957, you shall know a word by the company it keeps. What he meant is, I can't define a word precisely, but I can know how I use it and what words are around it when I use it. So we represent each word by a vector of bits or numbers. And that way we can measure how similar 2 words are by how close the vectors are to each other. And there's various mathematical ways to figure out how to do that. There are other classes at Stanford that will teach you all those details to do that. But here's an example. So here's 4 different words. And here's 4 dimensions on which they get a score. And I've made up names for those categories, but those aren't actually in there, right? To them, it's just dimension 1, dimension 2, dimension 3, dimension 4, but they're somewhat interpretable if you go and try to decode what's going on. And there should be hundreds of columns, not just 4. And from that, you can figure out the similarity. So the word Sweden is similar to Norway and Denmark, and less similar to Slovenia and Estonia and so on. You can project these words down into two-dimensional spaces. So here we've done that with a bunch of countries and capitals. And notice that this line between them is the same vector in each place. And so that vector, which is a set of numbers, roughly represents the capital of relation. And it kind of works. Doesn't always work, right? You can come up with other things that should have clear relations, and this doesn't fit at all. And here, even here, you see there's some that's a little bit off. So from Turkey to Ankara and Italy to Rome, it's not quite parallel to others. I think that's probably because of the different meanings of those words, right? And there are other models that try to split a word into multiple separate meanings. Here, you know, Turkey the bird and Turkey the country are conflated into one, so that's probably why it's off. And then we have this notion of Carte Rome, but there's all this kind of Rome in history that probably is conflating that. Okay, I went to this paper from 1987. Here's Ed Feigenbaum, who's one of the founders of computer science and AI here at Stanford, and Doug Letta, one of his students. And they wrote this paper called On the Thresholds of Knowledge, is an influential paper. And in it, they say generalization often involves accessing a body of general knowledge, one that's enormous, largely present in each person, yet rarely passed on explicitly. Things like water flows downhill, living things get diseases, and so on. And so what they were doing at the time is they were trying to build large language models and trying to build reasoning systems. And they said, the best source we have is something like this one-volume encyclopedia, right? 1,000-page encyclopedia. And it has all the facts in there. And it tells you that the Amazon is the biggest river. But as they point out, it doesn't tell you that water flows downhill. And from that is we can't learn just by reading text. We've got to laboriously program in all that knowledge by hiring a bunch of graduate students and having them type at a computer. And they tried that, and it never worked. And I think, in one sense, they were right. That if you only have 1,000 pages, it's not going to say water flows downhill. But if you have billions of pages, you get lots of good stuff, right? So learning resource for kindergartners, and there's a great lesson on water flowing downhill. And so all this stuff that they thought was kind of hidden, it was inside our brains, was never written down. That was true when you only had a few thousand pages, but it's no longer true when you have billions of pages. All that stuff is now written down. And so now we can build these systems without having to hire graduate students to type knowledge in. So how do we do it now? We want to train these models on training examples. It's too much work to have someone create those training examples. So we create them ourselves by saying, we're going to put in a new piece of text, and we're going to create a training example by saying, we're going to block out one word in the text, keep that hidden, and have the thing guess what word it is. And that's all there is to it. It just keeps on guessing, gets rewarded when it gets it right, and is forced to change if it gets it wrong. So what can you learn? Well, you can learn from pronunciation. Here's this International Phonetic Alphabet is a translation of this previous word. You can learn geography. You can learn agreement. So the word A comes before a word that starts with a consonant, and an comes before one that starts from a vowel. You wouldn't learn that from this one example, but after a couple thousand of examples, you start to learn that, and then you learn all the rest of the syntax besides just agreement with vowels. You learn arithmetic and metric conversion. You learn how prepositions work. You learn history. You learn how names work. All those things come out just by taking one sentence, blocking out a word, making the system guess, rewarding if it gets it right, and making it change if it gets it wrong. So here's something you can play with for a couple minutes. So click on that link. This is an older model, but it's still representative of what's going on today. So you can have a sentence here and you can type in your own sentence. Oops. And then see what it predicts what the missing words will be. So play with that for a couple minutes and then tell me if you find anything. All right, let's stop now. I think it's really interesting to maybe you can play with it more on your own. Did anybody have something they come up with they wanted to share? All right, let's move on. So we mentioned this idea that if something's written down in black and white and it looks coherent, we just have this idea, well, they must know what they're talking about. Reminds me of this book and movie called Being There, in which there's this character named Chauncey, and he's just a gardener, and he doesn't really know very much. He's not very clever, but he wears really nice suits. And so he's stopped on the streets of Washington, D.C., and he's mistaken for a pundit, and they put him on television, and and they say, what do you think about the growth of the economy? He has no, but he says, well, in order to grow the garden, you must water it. And they say, oh, that's so profound. That means you support the president's proposal for lowering taxes and so on. And so they feel like if you're dressed up and you look like you know what you're talking about, they'll believe anything you say. And I think that's a lot of what's going on with language models now, that we had this idea and your teachers been giving you essays to write on the idea that anybody who could write a coherent essay must understand what's going on. And now maybe that's no longer true. Language models can write a coherent essay without necessarily understanding what's going on. So the world has changed because of that. All right, so how do we do it? Here's a simple neural network. What we call a deep neural network is just something that has lots of hidden layers. So we start at the input. We stuff, compress that with a nonlinear function, send it to the next layer, and then get some output, and that's all there is to it. Currently, we use this system called the transformer, and so the idea here is, well, we want to be producing lots of output. We want to produce lots of words, not just one single word. So we need some architecture that does that. And here's what we have, where there's the input words here, the output words here. And the transformer is designed to have the capability to remember anything that came previously, whereas other models that we had before that tended to drop stuff that came earlier. Here, this attention mechanism says if something's important, it can go all the way through. So that's part of why transformers were successful. And then the other part was that it was done kind of all at once. Previous models had done one word at a time, and that just wasn't efficient for the kind of parallel GPU chips that we had. They were really good at doing parallel processing, so it was really good to put in all the input words at one time and then get all the output words in one step. And so this match between the architecture of this model and the hardware we happen to have meant that this model won out. And there are the classes at Stanford you can take to tell you all about that. All right. So now we built this model just by giving it sentences and hiding one word at a time and having it guess and correcting it when it was wrong. But now we want to make it better, right? So we have a language model. Language model is the probability of the next word given the context. But now we want it to be a chatbot or a useful tool of some kind. So we have to adapt it to do that. First part of adaptation is model selection. Which model do we want to use when there's many of them out there? So you choose a pre-trained model that's appropriate for your task. There's many of them out there. You could use multiple models, and you can do that with the process of delegation. So you have one master model that looks at the question and says, I think this guy can answer it best. Or you could send it out to all of them and have them vote. Or you could have the output of one chained into the next. You kind of set up your architecture that way. Then this idea of prompt engineering or few-shot learning, you give it some examples of what do you want it to do and learns to do that better. And there's lots of tricks, and this is maybe the most important thing to use these things better, is to learn these tricks for making better prompts. So instead of just saying, provide a data analysis report, say, describe the process you would use to follow, and give it details for what you want. And for the first prompt, you might get a good result, but it might miss some of the important parts. So give more context about what it is you're trying to achieve, give specific steps and terms. And that's important for two reasons. One is that it might go off and do something else. And secondly, having kind of keeps the model on track, right? So I said it has this idea of attention. So it can look into the past. But if it's got something to follow, then it's easier for the attention to stay on target, right? It's easier for the model to say, I'm generating this stuff. Now I'm processing this part of the question. Now I've moved on to this part. Now I've moved on to that part. Theoretically, it could have done that by generating all those parts on its own, but it's actually easier for it to something explicitly written down. Okay. Don't just say, tell me about dogs. Say, provide a detailed description of the characteristics, behavior, and care required for domestic dogs. Because there's lots of things you could say about dogs. If that's what you're interested in, say what you're interested in. Give examples sometimes. Being precise can help. So say, list 10 is a good way to get the results you want. Tell it the role to play. Say, serve as a historian, or explain it to me as if I was a 6-year-old. Tell it how you want it to interact. Be clear, precise, provide context. Role playing can be useful. Okay. It's amazing that this still works. So you give it a complicated math problem and gets it wrong. Then you say, think step by step, and it gets it right. And again, this is because of the way the architecture is built. It's got to have somewhere to put the intermediate results. And sometimes it can do that within the model itself, but it helps to put that in the output. Just as, if you're trying to solve a math problem, it's easier to do it with writing down your intermediate steps than it is to do it all in your head. Same is true for these models. Show your sources is important. It's one way to try to eliminate hallucinations. Act as if, as we said. Follow the guidelines. So give it some document that tells it what it should be doing. Follow up, right? So if it doesn't get it wrong, if it doesn't get it right the first time, say, here's some more details of what I want to get. And then if it seems it's got it right, ask it if there's anything you forgot. If it gets one part wrong, tell it to correct that part. Sometimes it's better to do that. Sometimes it's better just to throw it out and start over. But if there's one small mistake, you can often get it to correct that. Okay. Then this idea of fine-tuning. P is the pre-trained in GPT. And so it's a general model, but if we wanted to do a specific task, then we want to go beyond that general pre-trained model. And we can fine tune for a specific language, for a specific task, or for a specific subject, right? So you could take one of these off the shelf open source models and you can build them for a task you want to solve. Here's a playbook of saying, we start with one of the pre-trained models, we define what it is we're trying to do, and then we say, is there additional data that will help us do a good job on this, right? If it's just general questions about the world, the pre-trained model already has that. If it's some very specific task you want to do, then preparing data for that task can be really helpful. And figure out the strategy you're going to use and model that makes sense for that, and then train it on your data, evaluate the results, and iterate and improve on that. Okay, so finally, putting humans in the loop. So far it's been throwing a lot of text at the model, having it automatically figure out what's going on. It helps to have a human in the loop, and it doesn't have to be that much, right? So you can take a model that's been trained on billions of words, and with a few hundred examples saying yes or no, you can make that model better. So human feedback is limited in quantity, expensive and slow, but it can help. There's many ways of saying the same thing, and if the system just had to give one answer, sometimes it has two answers that are the same and they're competing against each other, and it doesn't know that. But if you have a human, you can say, yes, these are the same, they're both right. This answer is wrong. So supervised learning shows positive examples, but it's also useful to be able to say, don't do this, and reinforcement learning allows you to do that. And one note here is another reason I think we get so much hallucination is the way we evaluate these systems, right? We just say, what's your score? How many did you get right? Now, if I gave you a test, whether it's multiple choice, fill in the blanks or whatever, and said, your score is going to be the number that you get right, you come to something you don't know, what are you going to do? Well, you're going to put down something, right? So basically, the way we design the test encourages you to hallucinate, right? Said, I don't have any idea what this question is talking about, but I'm going to guess C is the answer, because all you know, I'll get a point if I get it right. And that's how we train these systems for the most part. And that feels like a mistake. Instead, we should say, get a point if you say, I don't know, and you didn't know. You should be positive for that, and you should be negative for guessing and being wrong. So we can build these systems to do better. Human judgment can help with these kinds of problems. And here's what OpenAI says they do to make ChatGPT. So the first phase is super expensive, right? Where they're going to have humans come up with correct answers. Explain the moon landing to a 6-year-old. And they have a human sit down maybe for an hour and write out a good answer to that, right? So you can't do that for a whole lot of questions, but you can do it for a small number, and that's helpful. Then in the second step, the human work becomes much faster. Now the model is generating outputs, and it's the human saying, yeah, this one's better than that one, right? So now you can move a lot faster. You can do hundreds per hour, maybe thousands per hour faster. And then in the end, the system is actually interacting with what it built from this. So it's leveraging this human feedback as much as you can, very small amount of super detailed involvement, then more, less detailed, and then automation. Okay. And what kind of improvements do you make with that? So here's something where there's fine tuning for bias, and in Turkish, so you translate this into English, and it says he is a doctor. Sort of just by statistics, that was more likely. But after the fine tuning, saying no, that's not quite right. It could be either one. Now two options are presented. Okay, and I won't read all the way through this, right? So this is prompt engineering and human feedback, what, how, and when you should do that. So let's just stop here and record your attendance.
And while you're doing that, let me remind you, Tuesday, we have a guy from Waco coming, so it's gonna be a really good talk. And you record, so really insightful. And as you know, the robotic car driving space changes every day, so you can probably see them on the way over here, way going down the street. That was not true last time we talked this.
No, in San Francisco, it's true.
In San Francisco, it's still true, and in parts of LA and Phoenix and so on. Anyway, don't miss that. And then Thursday, who's Thursday? What? Anyway,
Yeah.
there's another speaker, great speaker on Thursday. Is going to- Don't be out next week.
Is it B?
Probably.
Or is that next?
Yeah. Okay, everybody got this? We can write this up.